has the definition of an exponential function, anything in the form y equals a to the x, where a is a positive number. So sometimes your exponential functions increase from left to right. I'll get you to add the asymptotes in, because they always have an asymptote at y equals 0. And sometimes they decrease. So I think what makes this easier is if we actually make, I'll erase this. If we actually make a couple of graphs with real numbers. So here I have the graph of y equals 3 to the x. Every exponential graph has the point 0, 1. And then if you plug in 1, you'd have 1, 3. If you plugged in 2, you'd have 2, 9. If your exponential function has an a value, or what's in the brackets as a fraction less than 1, then it will be decreasing. So if I have 1/5 to the x, well, 1/5 would give me 1, 1/5. And I have the same shape, but decreasing. And what's neat with 1/5 is if you play around with your exponent rules. This 1/5 is like 5 to the 1 on the bottom. I can move that as a 5 to the -1. I'm going to use lots of negative exponent rules moving forward. And if I use my exponent rules of a power to a power, I can multiply them and get 5 to the -x. And if you think of your transformations, that negative with the x is a horizontal reflection. So if I had a 5 to the x graph, can you see it would be very much like this one on the left? And if you reflected it over the y-axis, it would match up perfectly with this one. In fact, this has the point -1, 5, flipped over perfectly. So I'll let you write those down, and then we'll move to example 1. So for graphing an exponential function, you have a parent graph without any transformations. You will always have the point 0, 1. Label that on that side. Then if you plugged in 1 for x, in this case you would have 1, 1/3. That's enough points to graph. The shape of an exponential graph looks like this. It always has an asymptote at y equals 0. And this is a basic parent graph for any exponential. So we can answer these questions. If you increase x by 1, you would multiply y by 1/3. So on here, if I increase x to 1 here, I'd have to multiply the y value by 1/3, and I would get 2, 19. In our example, this graph is going down from left to right, so we say it's decreasing. It has a y-intercept at 0, 1. But because of that asymptote, there are no x-intercepts. Our asymptote is at y equals 0. The domain is everything, and the range is bigger than 0. You could write that like this, or like that with rounded brackets. And that is a basic exponential graph. And you will have to graph any exponential graph, and I can change this number in there to anything. And it's not hard. right? If I did 5 to the x, you'd have 0, 1 and 1, 5. If I had 1/8 to the x, you'd have 0, 1 and 1, 1/8. And some of them will be increasing. In fact, most of them will have this shape of increasing. Because for the most part, we deal with numbers that are bigger than 1 here. 2, 3, 4, 5, 6, 7, 8, 9, 10. But if it is a fraction less than 1, then we get the shape that we have in our graph where it is decreasing. All right, questions for practice, you can circle 3, 5, and 7.